A factory made 3,000 toys in the first year. It made 99,000 toys in total, increasing the production by 445 toys every year. For how many years did the factory make the toys? So what's happening is, in the first year of its operation, a company makes 3,000 toys. And every year after this, it increases its production by 425 toys, meaning that in the second year, company would make 425 toys more than it made in the first year. So in the second year, the total number of toys produced by the company would be 3,425. Similarly, in the third year of its operation, it again increases the total number of toys by 425 as compared to the previous year. So, the total number of toys now produced by the company at the end of the third year would be 3,850 toys. And this process keeps on repeating until the total number of toys made by the company since the beginning of its operation comes out to be 99,000 toys in total. So what we have to figure out is for how many years did the company make these toys such that the sum of the toys made every year amounts to 99,000. So the number of toys made by this factory every year is an arithmetic progression, since the difference between the number of toys in any two consecutive years is always going to be a constant. So let's assume that this factory operates for n years and it makes some amount of toys in its nth year. Now, the sum of all the toys made by this factory up to its nth year of operation comes out to be 99,000, and we need to find out what this n is going to be. So we already know that sum of n terms in an arithmetic progression can be given by the average of the first and the nth term times the number of terms in that progression. So let's use this equation to figure out how many years it takes the company to make 99,000 toys. So we already know the sum of first n terms of the sequence. We are also given the first term of the sequence as 3,000. What we don't know is what should be the nth term of the sequence and how many terms does this sequence have. So we have two unknowns right over here. So how can we go about finding both of them? So one way to think about it is, if we could somehow figure out one of the unknowns in terms of the other one, we would be able to find out this thing. So let's use this pattern and see if we could relate these two unknowns. So in the sequence, every other term is d more than its previous term. In other words, if I have to get to my second term, I'll add this d once to my first term. If I have to get to my third term, I'll add d twice to my first term. And if I have to get to my nth term, I'll have to add d n minus 1 times to my first term, which is a1. So any nth term in an AP is always the first term plus n minus 1 times the common difference. So let's replace the value of an in our equation over here. And on doing that, I'll get Sn as n by 2 times a1 plus n minus 1 times our common difference d. So I think we have everything that we need now. So why don't you pause this video and find out n all by yourself. Alright, so let's do this together. The sum of first n terms is given as 99,000. N is something that we need to figure out, so I'll write that as is. And then in the brackets we have 2 times a1, which is 2 times 3,000, plus n minus 1, we still need to figure out n, times the common difference, which is 425 in this case. So let's simplify this expression to figure out n. I'll just make some space right over here. Okay. So on multiplying both sides of this equation by 2, on the left hand side we'll have 1,98,000 and on the right hand side we'll have n times 2 times 3000 is 6000. And if I distribute 425 over n and negative 1, I'll have negative 425 plus 425 times n, or 425n. Now we can simplify this further and add 6000 and negative 425, which comes out to be 5575. Oh boy, seems like we are getting ourselves a really big quadratic equation. I wish I had simplified this in the previous step. But anyway, let's move on and let's simplify this further. So on the right hand side, we'll now have 5575n plus 425n squared. Well, this is really big, so I'm gonna get my calculator. Okay, so I think 25 would be a factor of all these three terms. So let's divide 1,98,000 by 25 and we get 7,920. Was that 7,920 or something else? Let me get that back. Okay, so 7,920, and on dividing 5,575 by 25, we'll get 223. So here I can write 223n, and on dividing 425 by 25, I'll get 17. So this is 17n squared. Okay, so this is the simplest version because 17 is a prime number. So on subtracting 7,920 from both the sides, we have 17n squared plus 223n minus 7,920 equals to 0. So factorization seems a little tricky here. I'm simply going to go ahead and use the quadratic formula, according to which the roots of any quadratic equation can be given by minus b plus minus under root b square minus 4ac times 2a. All you need to do is identify the correct coefficients here. So here 17 is a, 223 is b, and negative 7920 is our c. So on substituting these values of a, b, c in this equation over here, the roots of this quadratic equation comes out to be 16 and negative 495 by 17. If you want to understand how did we get these values, you can go ahead and watch some videos on quadratic equation and see how did we use quadratic formula to solve this. So I'm going to go ahead and discard the negative value, as the number of terms in a sequence cannot be negative. So n comes out to be 16. Let me get my problem back. So this company made toys for 16 whole years, such that the sum of the toys made each year up to 16 years is 99,000.